First of all, Kollol leads the extraction team at Sensibill that specializes in machine learning-driven purchase document analysis. An engineer at heart, he made the leap into deep learning when LSTMs were still cool and believes they are even cool now. Controversial topic? Let's see. His interests include natural language processing, few-shot learning, and artificial life. And Fred is a machine learning engineer that has been working with machine learning since 2015. Main interests include MLOps, deep learning, and clean code. And if you're working as a machine learning engineer since 2015, you are a OG in the field. So we are in good hands today. So I also want to welcome Daniel. Daniel, I don't have your bio in front of me, but maybe you can just give us a quick intro as well.
I'm Director of Engineering at Sensibill. I'm just here to support the guys with any questions that you guys may have.
And with that being said, feel free to throw in any questions that you might have in the chat. We can go through those throughout the presentation, and I'm sure Daniel and team can pause to answer any questions that you have. So with that being said, I'm sure people will continue to join, but I will pass the mic over, turn off my screen, and let you guys get started. Thanks, everyone.
Great. Okay, just a quick disclaimer. Unfortunately, my building is kind of going through a fire alarm testing. So anytime you might hear a siren, and then I'm going to mute myself, and Fred and Daniel here is going to try their best to keep you guys happy. So, okay, with that, let's get started. I'm going to share my screen now. Okay, can you see my screen, guys?
Right. Yep, it works.
Cool. So welcome everyone to very aptly named deploying an E2E ML pipeline with SageMaker and what Amazon didn't tell you. So before we even get into there, this is our GitHub repository. I've also posted the link on the chat, so feel free to take a look at it. So again, you might be wondering, a company like us, we're not a cloud technology company. We don't sell any of those platforms. Why are we talking about SageMaker? So we basically wanted to deploy our infrastructure using SageMaker because it's very cool. It's really easy to work with, as in it's there. It has a ton of resources. But then, as you'll see, there are kind of issues out there that we faced, frustrations. But it's a great product, and I feel that if we share our experiences, our journey, it'll make it easier for you to not make those same mistakes. So that's why we've called this, what Amazon didn't tell you. So if we don't sell cloud technology, so what do we really do? So a bit about our company. So what we do is we are a receipt managed company, and at the core we use machine learning to capture receipts and extract details from there. Like you can see some of the extracted items out here, and by doing that we kind of reduce manual entry for people when they're trying to use that data for tax purposes or even some kind of expenses and reconciling it. But we also do more than that. We actually try to understand the receipts, and we kind of organize it, and we can do a lot of cool things with it. So that's what, at a brief, we do. We are trusted by some of the biggest banks in the world. That's because we kind of treat security very seriously. We are SOC 2 certified, and they are all over the world. And the reason they work with us is, as I said, we help them understand their customers better and how we might want to do it. So, for example, this is just a persona like Olivia. And by looking at her purchases, we know that she's a parent and an SMB owner. She's an educator. So we know that because of the kind of stuff she buys and the kind of courses she's taking or the books she's buying. This is driven by machine learning. And again, to reiterate, this is very much anonymized. It's highly secure. So our team is part of a key role, part of this process. And to kind of apply this technology, we used SageMaker and some of the learnings that we'll talk about. Quickly on the agenda. So SageMaker. So Fred's gonna talk a bit about SageMaker, very high level. Oh yeah, one thing I want to tell you here, this is not strictly a hands-on. So we will be moving a little fast because there's a lot of prep required. But as you can see from the repository, those who have the experience, feel free to set it up, and you can also pop questions on the chat and someone will try and answer it. Right, so coming back, so that's the SageMaker. And then as I say, this is like our journey. So we felt like putting it as a case study kind of a format makes it easier to convey. So we have 3 case studies. So the first one, Fred's gonna take that. It's about the SageMaker Python SDK to deploy models. He's gonna talk about what worked, what didn't work. I'll be talking about labeling jobs. That is the GroundTruth, SageMaker GroundTruth, and using something called step functions. And then we'll go into deploying a multi-model endpoint. So we are actually going to run through code. Let's hope that it's useful, but always feel free to put something on the chat. With that, I'm going to hand it over to Fred, who's going to talk about SageMaker first. Here you go, Fred.
Okay, let me share my screen. Okay, so as Kollol already introduced me, I am Fred. I am a senior machine learning engineer here at Sensibill. I'm going to be talking a little bit about SageMaker. I bet that most of us here have heard about SageMaker. I don't know if all of us have had the experience of actually doing something with SageMaker, but let's just go through a little bit. Let's just first answer the question, what is SageMaker? So SageMaker is not a tool. It's a platform. It has lots of tools. It's all 100% managed. So if you need a machine to train your model, you don't need to set up any EC2 instances or anything like that. And SageMaker has services for a lot of stuff. Here are some of the services that it offers. I'm not going to go through every single one of them. It's just so you have the magnitude of what SageMaker is. It has tools for you to prepare your data set, build your machine learning pipelines, train and tune your models, and deploy them to production. So I'm going to present a few concepts here that are going to be useful for the rest of this workshop. So the first thing you see when you enter SageMaker on the Amazon console is that you have some drop downs on the left side of the screen with a bunch of resources. I'm going to be talking about what I consider to be the very basic building blocks for someone to train and deploy a machine learning model. So these are the 4 resources that I'm going to be talking about. So if you want to train and deploy a model, you've got to learn what these 4 are for inside the Amazon SageMaker context. The first one, the training job, it's quite self-explanatory, right? You give it some training scripts, some training code and parameters. You could call them hyperparameters, if you will. And if all goes well, it spits out a model file for you that you can use to do whatever. You can just use that model file the way you want it, or you can continue down the path to deploy this model file. For that, you'll need to create this model object, model resource inside the Amazon SageMaker environment. A model for Amazon SageMaker is a model file, the file containing the weights and whatever you need to create a model, and the inference code. That is code that tells the running environment how to actually use your model to predict on unseen data. We're going to be talking more about this later in the talk. It's just so you know what you need to create a model. And then with a model, you can create an endpoint configuration and an endpoint. To create an endpoint configuration, you'll need variants. And this is where you'll be deploying stuff like A/B testing. If you need to A/B test two models at the same time, you can do it here at the endpoint configuration. And for a variant, you're going to need a model and the configuration for your instances. So you got to tell SageMaker what kind of instance this model will be running on and how many instances you'll be needing. So putting this all together, this is what you get. So if you want a custom machine learning model running on SageMaker on an endpoint that you can just hit with data and it's going to return to you a prediction, you're going to need some training code, some inference code, and some parameters to set up the instance and the hyperparameters of your training job. That's cool, but I also want to talk a little bit about SageMaker GroundTruth. It's something that we're going to talk more about in this workshop. Kollol is going to go through some of its concepts, but I just want to say one or two things about it. It's just that SageMaker GroundTruth is a tool that helps you label your data. So it's not every time that you can get labeled data out there in the wild. Sometimes you gotta get your hands dirty and actually label your data. So SageMaker GroundTruth is the tool for you. So here is a screen showing a image classification GroundTruth job. Here you can classify this image as a bird, for example. But this is just one instance of GroundTruth running. You can actually customize the screen the way you want it. You can write JavaScript and HTML code, and Amazon SageMaker is gonna do all the workflow behind the scenes to actually get that label and put it in your S3 bucket or whatever is highly configurable. You can do whatever you want with it. And Kollol is going to be touching more on that subject later. So with that said, let's go to our first case study, which is using the Python SDK to deploy models. So before some background on how we actually came to this case study. So here at Sensibill, we have lots of users that we want to understand more. And one of the ways that we created to understand our users better is through user segmentation. So the idea here is that we can identify a few users as being, I don't know, homeowners by just looking at the receipts that they provide. One of the ways that we do this is we get the user's receipt and we go one by one flagging them. So we identify some receipts as being receipts that indicate, for example, that a person is a new parent, or that a person is a pet owner, or that is a homeowner that is doing some kitchen renovation or this kind of stuff. So after we flagged those receipts, we can identify what segment that person or what segment or segments that person belongs to. So to do that, one of the models that we created is a pretty simple model. It's an attention layer with a multi-layer perceptron after. So here we can see from the width of the arrows here is representing sort of like the attention weights for each item in the receipt. So if a person goes to Walmart and buys bananas, diapers, cupcakes, formula, carrots, and dog food, where the attention weights should be larger for diapers and formula if our model is trying to flag new parents' receipts. So while we were building this, this was our pretty basic, simple plan for a starting machine learning pipeline. This was actually my very first experience with SageMaker. So my number one priority was to have something really simple that could get the job done using SageMaker. So I was just gonna set up a training job to create a model, evaluate that model, and if the model was good enough, I would update the endpoint that was already deployed. So let's go to the demo part of this presentation. Just let me change my screen. So can you see my screen? Yep.
Yep, it works.
Okay. So first of all, if you're new to SageMaker and you want to do something like this, the very first thing you're probably going to do is go to Google and type in something like how to deploy, train, and deploy a model, right? And almost invariably, the guides that you're going to get are going to be using the Amazon SageMaker Python SDK. So I've gone through a lot of these Google results, and almost all of them are using the Python SDK to deploy models. So it seems like the way to go if you want to deploy a model on Amazon SageMaker, right? So I'm going to walk you through on how you could do that with the Python SDK. So the first thing here, when you go into the SageMaker screen on your Amazon console, you can click here on Notebook and click on Notebook instances. I'm gonna create a new Notebook instance so we can work on our model. This is the screen for creating a notebook. So you can give it a name. You can choose your instance type. If you need a bigger machine, you can do that here. There's a lot of additional configuration that you can do. You can change the disk size. You can give it a VPC. You can even attach a Git repository if you have one configured. So you click here on Create Notebook Instance, and it's going to create one for you. I already created one because it takes quite a bit of time for this to actually go to in service, but this is how you do it. So let's go to the instance that I already have created. So to show you how you can use the Python SDK, I'm going to be walking you through an example that is actually the SageMaker's official example. So if you click here, you're going to go to this examples repository. This is where I got this code from. I'm going to be working on it. I'm going to be doing extra stuff that the original example didn't do. But let's go. I already executed the first half of this demo because particularly the deploy function takes a bit of time. So I'm just going to explain what this is doing. So this is the Python SDK from SageMaker. This has a lot of functions and objects that can help you through the process of creating and training a machine learning model and deploying it. So it actually creates a default bucket, an S3 bucket for you. So you don't even have to set up anything before this. This is going to create an S3 bucket for you if you're executing this too. And you can have access to the execution role that this notebook is running on. And if you use the default role, it's going to have permissions to actually train models, to do a lot of the stuff that you need to do to create a model. So this comes pretty much out of the box. You don't have to set up anything. And for this example, I'm going to be using the classic MNIST example. So I'm just here downloading the data set using Torch Vision. Nothing special about this, just doing some transformations before we can train our model. And after we've run this cell, we can see that this data directory appears in our Jupyter lab. Here's where our training and testing data is located. So with this data directory, we're gonna have to upload it to an S3 bucket. We're gonna use the S3 bucket that SageMaker already provides to us, so we don't have to set up anything. So the way that a training job works is that you have to upload your data to an S3 bucket so your script can read the data and train your model. The next step is to create what SageMaker calls an estimator, not SageMaker, but rather the Python SDK. This estimator is going to be the object that is going to help you to train your model. I'm specifying a few things here. The main one is this entry point. So when you're creating an estimator or a training job, as I said earlier, you're going to have a training script or a training code. This is this mnis.py. It's a pretty regular training script. There's nothing too special about it. You're going to set up it just like you would with any training script. The only thing that you have to do is to define these special parameters, CLI parameters, to read the data and save your model. So the most important ones are these two. Oh, sorry, these two. So this first one, model directory, is where you're going to save your model. So after your training script runs, you're going to have to save your model in a special directory. So SageMaker knows where it is, and it can upload that model to S3. So you can read that model later. And this parameter here is going to be reading its values from a special environment variable. It's the same for the data directory. The data directory is something that you specify when you're calling the fit argument, the fit method in the Python SDK. And this directory is going to contain this data directory that we downloaded earlier. So yeah, so you specify which script you're going to be using. You specify the role the running instance is going to have, the Python version, the PyTorch version in this case, how many instances you want to use. So in this specific example, we're going to use 2 instances. So it's a distributed training. It's going to set up 2 EC2 instances for you to train your model. And you can specify what type of instance you're going to be using too. And here in the hyperparameters, you can specify the parameters that you're going to pass to the CLI of your script. So here we have the epochs parameter. We can set that up here. So nothing special about it. After you created the estimator, you can call fit and you specify the data channels. So a data channel is a directory in S3. So if you come here and see what inputs look like, it's a path to S3, and you're giving it a name, which is training. So your environment variable is going to be SM_channel_ the name that you gave. So you can specify multiple channels. Some people use this to do training and testing. So you can specify other inputs for testing, this sort of stuff. And you're going to run this, and it's going to create an instance for you on EC2.
Fred, let me quickly pause you. There's just a quick question on how to set up the containing environments by Holly. And the question is if by default, the container environments are null.
Container environments, what do you mean by that?
I just mean, can you hear me? So if you go to the like index.py, so you mentioned there's like most important to set up those like container environments. So you set the default as OS the inversion SM model DRR. So I think by default, if you don't do anything, I think by default it's none. Do I need to do anything before to set up this to give some value to that?
You mean this variable here, right?
Yes, yes.
Yeah, so you don't need to do anything. There's nothing special about doing this with command line arguments. It's just that this is like the recommended way of doing it. Normally, what SageMaker is going to do is going to set an environment variable for you. So this environment variable is going to contain the path for the directory, for a local directory. I'm just setting this to a command line argument so you can run this stuff locally and test your script. So this is like a recommended way. You don't have to do anything. So for this one in particular, SageMaker is going to take care of it. This is a default environment variable that SageMaker sets for you. Does that answer your question?
Yeah, I think so. So I think it's like I better to set up this argument like example model DRR like by hand. So don't use the default one. For example, I just link to my S3 path to that.
Oh yeah, you can do that. So when calling your script, let's say, I don't know, Python mnist.py, you can for sure just tell it what directly to use. So normally this is really useful if you're testing this script locally or running this on another environment. That's why we normally give this this interface, this command line interface for it.
Okay, thank you.
Cool. You're welcome. Yeah, and do ask questions if I'm going too fast. Yeah. So let's continue. So you've ran your fit method, and this is going to spit out a bunch of logs for you. So I'm just searching for one particular log. So test set here. At the end of our script, I'm just printing the test set accuracy, and this is what you got. So this actually created 2 EC2 instances and ran our training code. This was 100% managed. I didn't have to actually configure any EC2 instance or anything like that. I just needed to set what instances I wanted, and SageMaker took care of it. So yeah, now I know that my model got 91% test accuracy. I can deploy it. And this is really easy using the Python SDK. You can just go here and tell it to deploy to a ML M4 X large instance. I'm just going to use one instance for serving. Like if you have a lot of traffic, you can set this to, I don't know, 50 if you want. It's going to take care of it for you. And this is going to create an endpoint for you. So let's go back to the console and see what it did. So the first thing it did here at training jobs is it created a training job. This is when I call the fit method. You can see stuff here like how much time it took, the billable seconds, and what training image it used, how many instances, and it's going to have the training didn't run for very long, but if it ran for like more than 5 minutes, you were gonna get like CPU utilization here, memory utilization. So yeah, this is our training job, and here's the output. So remember that we saved our model to a special directory, which was the environment variable that SageMaker provided to us. If we save our model there, SageMaker is going to take care of, first of all, zipping that model and uploading that model to our S3 bucket under the name of model.tar.gz. So this is going to contain our model weights and model parameters if you saved any. And if you come here and you type this, you can see here is the model data that the estimator saved. Before I called the fit method, this was null, but after we have a model, a trained model under here. So yeah, after you call deploy, you have a predictor. When you create a predictor, what it's doing is creating an endpoint for you, an endpoint configuration and an endpoint. So you come here under inference, you can check the endpoint configuration that we created. And the endpoint configuration is going to refer to the model that we just trained, which is in its turn referring to the model data that we created, and created also an endpoint with that endpoint configuration with a URL that you can call with data. The Python SDK also has some interfaces for you to call that endpoint. So with this predictor is pretty much an interface for an endpoint. Does anyone else?
There's just one question, which is, can you use any Python framework in your training script?
There are ways of actually using anything that you want, but SageMaker provides you a few out-of-the-box frameworks like TensorFlow, MXNet. It provides extreme gradient boosting. So there are a few that you can use out of the box. But if you want something that is not provided, if I'm not mistaken, you'll have to create your own training container. So what you're using here when you're using the PyTorch estimator is you're using a training container, like a training Docker container that Amazon provides to you. But I don't have the list handy, but it provides like quite a few. You're probably covered.
Thank you.
You're welcome. So as I was saying, this predictor is pretty much an interface for your deployed model. So for example, we deployed an MNIST model. So I don't know, let's test it. Let's create a dummy image. It's going to be all zeros just for testing. And we can call the predictor like so. Yeah. Oh, yeah. So if you worked with PyTorch or TensorFlow before, you know that you have to add batch and color channel here. So yeah, I missed that. So there you go. This is your prediction. Normally, if you want to know what digit this is, you're going to do like a maximum argument. This is like a blank image, but let's see. Just so we have like a proper example, we can take a look at it. Yeah, this is the image that we just tried. We can sort of make it look like a 1 by doing this. So now it predicts a 1. It's silly. It's just for an example. Okay. So yeah, you trained your model and your model is doing great. You deployed it to an endpoint. People are using it. Probably set up some Lambda function to actually interface with the model. Don't actually serve the model endpoint directly. It's just good practice. But let's say you didn't do that and people are using your endpoint. So now you want to improve your model and you want to update that endpoint. And the thing is, when you're reading through the Python SDK documentation, it's going to tell you to deploy your endpoints, but it's never going to quite touch on the subject of updating an endpoint. I mean, if you read like the main documentation here, there's a brief reference to update endpoint. So why would you want to update an endpoint instead of deploying a new one every time you train a model? It's just because there are some systems that are already calling your endpoint. So it's quite natural that you want to update an endpoint instead of actually deploying new ones and keeping track of what you deployed before to erase it or anything like that. So the natural course is to train a new model and update the endpoint that you already deployed. And the documentation here is telling us to use this update endpoint parameters together with an endpoint name parameter. It even has an example on how you could do that. So yeah, let's try it. So, okay, let's first improve our model. Let's train a second estimator, but now we're going to train for longer because we think that this should improve our model. It's pretty much copying what we already did before. So yeah, this take a bit of time. Any questions while we wait for this? I can reach the chat.
There's a question with chat. So does this offer model versioning capabilities as well, along with the updated endpoints?
So, okay. So for model versioning, you can, if we update, I don't know what kind of model versioning you're referring to. So if you update an endpoint, you're not going to erase the previous model. The previous model will be still on your S3 bucket, and it will still have a model object on the SageMaker console. So what kind of versioning do you want to do? Would that cover you?
Yeah, I was looking for some kind of monitoring between the two versions, what has changed, whether there's any drift, things like that. Any kind of, if you can compare the older versions and the newer version of the model.
Okay, yeah, so variants of the model. SageMaker does support variants for you to actually do some A/B testing if you want. I'm not entirely sure how to do that with the Python SDK.
Okay, thank you.
So yeah, just a spoiler, like working with the Python SDK is not easy. The documentation is not great. So there may be a way of doing that, but I've read through a lot of the documentation, maybe all of the documentation, and I've never seen it. So I don't know, maybe someone can answer that question better than me.
There's another question for, is there any notion of canary deployments or shadow mode with a SageMaker endpoint?
Yeah, with variants, you could use variants, yes. So this is not related to the Python SDK, but when you create an endpoint configuration, you can actually add multiple models and you can give it weights. So depending on the weight, you can actually give more traffic to a model or other. So you can do canary releases using this. So yeah, it could support that, yes. Again, not 100% sure with the Python SDK.
And does it provide experiments tracking, logging functionalities like MLflow?
So the logging functionality that this provides is pretty basic, I would say. There are some metrics. I haven't set up metrics here. So you could, doing this with Python SDK, again, you're kind of spoiling the point of this case study, which is
skip.
Python.
Like, answer this in the future. Like skip. Like we got the question. We're gonna answer that in a minute. Hold on tight.
Yeah.
I can add to it. With SageMaker Studio, I think they are supporting something called experiments a la ML Flow. I just taken a glance at it. So again, one thing about Amazon is like they have a huge offering, right? It's like pizza with millions of toppings, and you just don't know what topping to use, and there's no way to know which topping will work for you. So this is one of those cases where, you know, we are not using the feature of AWS yet, but then, you know what, we might explore it. So that's under SageMaker Studio. That's the most I can tell you right now.
Yeah. So let's go ahead and take a look at our model. So we see here that our model actually improved, right? Because we had 91%, now we have 96%. So yeah, successful at improving our model. Now we want to update our model, and the documentation here tells us to use this update endpoint and the endpoint name parameters. We're gonna do just that. Okay, let's copy this. We're gonna call this the second predictor from the second estimator, right? We're gonna keep the same parameters. We're gonna update the endpoint. And we're gonna tell which endpoint we're updating. So we're gonna have to give it the endpoint name. We can get that from the first predictor, like so. Just put that in another cell. So here we got our deployed endpoint name, so we can reference it here. And we run it, boom. Yeah, so apparently we're doing some deprecated stuff. Yeah, so update endpoint is a no-op in SageMaker too. Okay, so apparently we're reading outdated documentation, right? That must be it, but let's see, we're on the stable documentation. Maybe they didn't have time to update it, but I mean, we are on SageMaker SDK 2.0 for quite some time. So yeah, this is, the documentation is wrong. That's the point. So this happens more often than not with the Python SDK documentation. Like you follow the steps, and the recurring theme here is that there's a happy path. And if you follow that happy path, you're gonna probably get an endpoint running and all. But as soon as you want to do something that is a bit different from what they tell you to do, which is deploying a new endpoint for every single model that you have, you're gonna bump into problems. This is just one instance of it. So yeah, so the documentation is just wrong. I don't know what to tell you. This doesn't work. It's on the main documentation of the Python SDK. So yeah, when I was doing this for the segmentation, user segmentation model, I was like, huh, now what? What do I do? So I'm just going to take a look at what it's telling me to do. So if I follow this link, if my internet can cooperate, it should have this link already, right? Okay. Yeah, so the documentation that it shows me is use version 2.x of the SageMaker Python SDK. Yeah, sure, I want to do that. So here I see update endpoint in deploy. The update endpoint argument in deploy method for estimating models is now a no-op. Please use the predictor method called update endpoint instead. So yeah, if we want to do this, we're going to have to create a predictor object and call the update endpoint. Okay, that's a bummer. Let's see. So let's just, we know we have this predictor object, right? Let's just pretend that we don't. So, okay. We're going to have to create a new predictor. So 1 second, we got to import it. it tells me to give it an endpoint name to create a new predictor. We already have that. Okay, with this existing predictor, it's telling us to call the update endpoint method. And this update endpoint method is going to take your model name that you want to update. So you can update the initial instance count, the instance type, the accelerator type, a bunch of stuff. And you can also update your model name. So yeah, probably that's it. We're going to update the model that this predictor is pointing to. But what is our model name? I mean, we trained a new model, right? We should have a new model, right? Okay, let's see our model name. So this is the first model that we trained, not the actual model that we retrained. We trained a new model, right? So it should be here. So yeah, if you go back to the documentation, you're not gonna see this, but when you train a new model with the estimator, you're not creating a new model object. The model object is being created when you call the deploy method. Again, it's hard to figure this out when you're doing this for the first time. And you're just gonna have to figure out that you don't have a model yet. You're gonna have to create it. So what does that look like? Well, if you did a bit of research like I did when I was doing this, you're gonna figure out that the second estimator it has a create model method. And now we can see a new model here, or not. I don't know. So yeah, we have a model name. It should be here, but it's not. Okay. Well, we can use this either way. I know we can. I don't know why it's not showing there. So yeah, now we can do this or not. Missing initial. Oh yeah, you gotta specify the instances again. Since you're deploying a new model, you gotta specify all the stuff here. Yeah, we don't have a model. Why not? So okay. See, well, not easy to use the Python SDK. Again, I did this earlier. I thought it was working. We can do this another way. So our new model, let's create the model. The Python SDK is just not working for us. Yeah. Can we do this like so? You gotta have an image. Okay, yeah, I guess, I mean, the main point is being passed that using Python SDK is kind of a bummer. Why is this not creating a model? Any clues? Any clues in the chat? Because I have none. This should be this compile thing. No, I don't know. Okay. Yay. Yeah, so deploying the model, I see the chat. Deploying the model is going to deploy a new endpoint, which is what we're trying to avoid here. Let me check. Okay, I have a reference for this. Let me look at the chat.
So there, yeah, Roberto mentioned that maybe the model is being deployed under the hood and it should be synced.
It needs to, sorry?
Roberto is asking if the model is being deployed under the hood and is not yet done.
No, I don't think so.
So
It
create a
shouldn't
model
be.
doesn't create the API object yet.
No, the API object, no. So let me take a look at the notebook that I created with all this stuff. It should have an answer for us. Deploy failed. The second estimator, create model name, update endpoint. Yeah, that worked out for me before. So yeah, this failed.
Are you on the same region as the other tests? Maybe it's a deployed version.
Maybe it'd be third time, maybe just try it again.
The what? Sorry?
Maybe just try it again, you know? Things don't work, try it again.
Yeah. Again. You see, there is a model name here. This is the weird part. There is a model name, which is not the same one. There should be a model. Is it deploying to a different region?
Can you refresh there?
Can you try AWS 1 or something?
That shouldn't be it. That really shouldn't be it. No.
Well,
yeah, so
that's the whole point.
I mean, that's the whole point. Yeah. I think this is a successful demo of the point that I wanted to make, which is, let me change my screens back. The point that I wanted to make was, don't use the Python SDK if you're deploying stuff to production. Just don't. It's a bad idea. The documentation is not good. It hides a bunch of stuff from you. Like, the proper way of doing this is actually learning about Amazon SageMaker and all the resources and doing it yourself with either the AWS CLI or the Boto 3 package, or use CDK for your production stuff. So yeah, the point that I wanted to make is documentation is not great. I know that SageMaker has this SageMaker Studio. I've never actually used it. And my opinion is that when I'm reading through the SageMaker Studio documentation, I get the same vibes that I get from when I'm reading the Python SDK documentation, which is, here's a happy path. Do this and you'll find success. And the way that things normally work with these tools in Amazon is that, sure, if you follow the happy path, you're going to have exactly what that guide is telling you what you're going to have. But then if you want to tweak stuff, you're going to have to get a PhD on the tool. You're going to have to learn a bunch of it. The documentation is not going to be great. So this is an opinion. I haven't used the Amazon Studio, Amazon SageMaker Studio yet, but I do get the same vibes. So that's why we at Sensibill, we always used Boto 3 and CDK to deploy anything that goes to production. And yeah, that was my part of the workshop. And
a minor note is that we have successfully deployed, but using Boto 3 as a tool, because we were able to get something stable and it actually worked. And it's a far more stable tool, and using that in CDK, I think David mentioned on the chat using Terraform, and yeah, Terraform also works. But if you get effectively, SageMaker is a great tool, but there are ways to use it. And the standard ways feel very simplified, and you can get a lot more benefits if you go through like a more direct approach.
Yeah. So before I kind of go into my part, are there any questions for Fred? I know there are a couple on the chat.
There was one question by Nicola on the endpoint authentication capabilities of SageMaker. We typically leverage via Lambdas, right, Fred? And that's the Lambda that's managing the authentication.
Yeah, we typically use IAM roles for this kind of stuff. I don't think it supports any more advanced authentication. I think that you can get resource authentication using IAM, but that's it.
Sounds good. Thanks.
Okay, so there's one more question.
By API directly, do you mean AWS API or like through Boto?
Either. You can use either. Normally we use Boto because it's a bit simplified and it's well documented.
Yeah, I think we are going to talk about deploying using CDK, and then there is a bit about using Boto. And on production, we actually even use the JavaScript SDK because some of our components are in JavaScript. So it really matters. It depends on what your pipeline looks like. Okay. Data drift. There's one more question on data drift. So I don't know if you have any experience on that, Fred.
Not particularly, but I know that SageMaker has monitoring capabilities, even profiling and debuggers. What I do know, and again, is that there is a default profiler and a default debugger. I don't know about default monitoring, but if you search for it, you're gonna get a nice monitoring tool for you. So if you want to customize the profiler or the debugger or the monitoring tool, it's a bit complex. You're going to have to read through a lot of documentation to do that. I haven't done it particularly, but I know it's a bit complex.
Yeah, so the last question, what's your architecture in production? So I can answer part of it. So we do use SageMaker. So we have things like labeling jobs, we have training jobs, and we use the endpoints. And some of it is instrumented with step functions. And then we use a combination of CDK and we have our own versioning system. And when it comes to monitoring, right now, we haven't really explored their model monitoring capabilities, but we have a process where we sample data from the live environment, and then we annotate it, and we look at what is the drift in terms of accuracy. So that's how we do it. I will touch a bit about the pipeline there when it comes to my section. So should we take a quick break or should we just go on?
Yeah, it's the 1 hour mark, right?
Yeah.
Why don't we take a quick 5, guys, and we'll let people go to the washroom, grab a drink, we'll grab a coffee, and we can regroup?
Yeah.
Yep, works.
Okay. Sounds good.
Back by 2:06. Okay, I think everyone's back. It's 2:06, so let's continue. Welcome back, guys. Now I am going to be talking about labeling jobs with step functions. Fred touched a bit about the GroundTruth labeling job, and I will come to it as like a case study. So what was the problem? So anyone who uses machine learning, like Fred said, at some point you have to label your data. We have our own internal labeling tools. And we found the SageMaker GroundTruth pretty appealing. It's managed, it takes care of UI, it's very flexible. So we wanted to use GroundTruth for sure. But how? So the problem is we want our data team to, import data and trigger new jobs. So they should be able to, run the job, label it, and once it's labeled, this SageMaker GroundTruth has its own format. So we want to convert it and store it back into data store. So our architecture is we store the raw data and the labels together. And for this to happen, we need to ensure that once the labeling is completed, all that is triggered automatically, right? So here's like some of the points that we cared about. And we also want alerting if something goes wrong. This is production, right? So we need to get something like a Slack alert. So how do we do it, right? But before that, just wanted to show the labeling job again. So this is how it looks like. So we get receipts, and this is a bounding box bounding box task. I'll explain what the task is. And you can see one of the labels is a merchant name that someone will like draw a box. And a bit of terminology on GroundTruth before we go more into it. So the GroundTruth as a component, it requires a couple of things to work. It needs to be configured with a lot of like S3 related data. But mainly you need something called the input manifest. It's basically your input data. You store it in a S3 bucket, and then you start the job. It's gonna generate what is called as a task. So one task is one job, one annotation task, like one receipt, for example, that you're labeling is one task. There are quite a few different tasks that you can use out of the box, and you can also customize it. This task goes to something that is called as a work team. This work team can be, Amazon Mechanical, it can be a Mechanical Turk. It can be your own private team. I think those are the two options so far. And I think AWS also provides their own system. And once they label it, it's going to send it to all the annotated data into this thing called an output manifest. And while it does it, every time it gets something annotated, it's going to use something called a post-processing lambda. So actually there are two of them. There is a pre-processing and a post-processing lambda function that gets called for any input changes you want to make, and one on the output side. So that's like some of the terms. We'll go into more details. Like I just wanted to set the context. So that was our problem, and the first solution that we kind of came up with was, to do all the conversion, why not use that post-processing lambda that they provide? So Amazon does talk about it. If you look into their documentation, they said that you can also convert it into a format you want, and so on and so forth. But as we said earlier, recurring CMS things aren't what they actually seem. So it didn't really work for us. So the first reason was that it doesn't have all the information that you want. For example, all the metadata about the file itself is missing. So that's one thing. It's difficult to test because it's getting sent for every label that you annotate, and it's hard for us to test it out. There's no way to monitor it. And finally, its purpose is for consolidation. So how labeling jobs works is you can have multiple people label one, let's say, image, and then you can actually, you have a Lambda function that can look at all of them and choose the best one. So that post-processing Lambda I was talking about, it's mainly for consolidation where you kind of pick the best one. So basically it doesn't work. So instead, what we ended up using is called the AWS step function. I'll go more into it, but basically it is kind of an orchestration framework. And you can essentially, once the whole labeling job completes, you can trigger your Lambda function, or you can trigger a training job, for instance. So you can do a lot of chaining if you want it. So it's very scalable. You get all the information once the whole annotation is completed. So yeah, so you know what, we'll use this. And then, okay, a bit about step functions before I go into the challenges is what is really a step functions. I don't know if you guys have used it. So this is an orchestration framework where everything is like a flow chart. So you have what is called as a state machine or a workflow where you define tasks. So each of these things like seed the dynamo table or a for loop, these are like a task. And then an instance of your state machine is called an execution. So you can kind of execute arbitrarily complex flows. And people actually use this for their pipelines. For us, we wanted to use it so that we can just go from a labeling job to all the data being like post-processed. So with that in mind, we are like, let's do it, the challenges. So just like the PyTorch SDK before, no guidelines at all how to use this with a step function or examples. And also there is no direct support in the Python SDK. So they even have another SDK that is called the data science something. It's called the data science step functions SDK. It's like a huge name, and then it has no support. So how do you get around it? So let's dive in at this point. If you have set up a repository, this is the structure that you'll see. The one that we'll explore now is called labeling jobs. If you are interested in like running this out, go through the readmes. They'll give you an idea of what needs to be set up. Basically, you need to set up a lot of things around IAM roles and your accounts and your S3 bucket. But if you have your time, you can actually make this work. And then let's hop on into this notebook out here, which is your step functions. So there are some guides out here, so you can go into them and see how they work. But as I would, yeah.
Can you increase the font size a bit?
Okay, I think I increased it, but I guess it's still very small. And is that fine? Or more?
Yeah.
That's good.
Oh, yeah. The other one was fine. Yeah.
Okay.
Cool.
Yeah. Please like stop me if you have any questions. Interestingly, when you share your screen, you can't see the chats easily. So please stop me. Okay, so here, this is the setup. So like I said, this is the terminology. And oh yeah, before we go in, someone asked us what in production it looks like. So we have one of these flows. So this is something we have built on top of using Jupyter as UI, and it runs Photo 3. So you can see in our production pipeline, you can see all these different labeling jobs that are queued here, and you can start a new labeling job. All this UI is done using Jupyter, very straightforward, and you can actually start it. It's going to kick it off using step functions. So quick preview here. Coming back, so we said that it needs some configuration, right? So when you create a labeling job, the whole bunch of things that it needs. The most important ones are probably the manifest URI, that is the input, the work team, and I think the rest are like generally pre-filled if you use the console. But here we are going to automate it using the step functions. So we will have to provide a lot of this ourselves. So what are the first steps? So first, we need to have a bucket that holds our input data. So if you look here, we have some sample data here. They are the two received images. And the first thing we're going to do is we are going to set up a bucket. So I have already set up one bucket. And you need to make sure that it's set up with something called CORS. So this is something that lets the tool work. Otherwise, it'll break. It's not clearly visible always, but you have to make sure that this is done. So let's copy the data. Image 1, image 2. Okay, so this is the format of the manifest file. I've already generated it here. So you can see how that looks like. So this is something called as a JSON lines format. So each line is a JSON. It has something called source ref. So essentially location of your the image, because this is a bounding box task, and then an ID you can pass. And I think that ID is important for us because we want to store the labels along with this image right here. Okay, so go ahead and run this. And then we copy that to another S3 location here. Another thing is called the label category file. So this is something that you need for the bounding box task. So whenever you are trying to label a bounding box, you need to provide the labels. So we have two labels here. In this case, our task is we're trying to find where the merchant name is on the receipt. And we have a reject button in case the image turns out to be like garbage. So that can happen. So two category options here. We've uploaded that. And last is the UI template. So this is something that you can set it up yourself. You can build an entire like React-based UI if you want, very complicated, 3D kind of labeling. It's completely up to you. But you can use some of these tools that, or some of these like utilities that SageMaker gives you. So this one of them is the crowd bounding box. And you can pass some of these things like, what are the labels, what is the header, and some instructions. And I'll shortly show you what this thing actually looks like. And we'll do a little bit of labeling. Okay, so this is done. So now that's like the data part. And now let's look into the step functions part of it. So we want to hook this up as a flow. I have set up one already just so that you can illustrate to you, but we can set it up as another one. So this is what our flow looks like. So we're gonna start by calling the bounding box labels. So that is the labeling job. Once that is done, we are gonna call a Lambda function that's gonna do a conversion. And that's about it. It's pretty straightforward. But we also have some, that's the happy part. So we also have some failure handling out here. So we have this second Lambda function that is going to send us a Slack alert. So in the code, I haven't specified the URL, but I've given you a guide. So you can always set up a Slack bot that can send you an alert if something goes wrong with your pipeline. So this is very simple. But again, as I said, you could make it way more complicated. You can have a second labeling job, someone to audit it. You can go into your training like step. And if you look into Amazon, they even let you go and deploy. So you can essentially build your entire pipeline using just step functions if you wanted to. But what does it look like? It's essentially just a JSON file with some special like terminology. Okay, so that is what it looks like. And when you execute it, you actually can pass some input to it so that you can parameterize. In case for us, it's the labeling. So stuff like that you can parameterize when you run this. So let's look at how we actually do that. So we need to use this SDK called step functions, which is that huge, like the data science SDK that I was talking about, right? It's a pretty large name, AWS Step Functions Data Science Python SDK. Wow, 1, 2, 3, 4, 5, 7. Wow, that's a really long name. But that's how we kind of use it here. So let's go ahead. So, and again, you need to do some setup, make sure your account is all set up. There is a role that you set up. And if you look at the README file, it'll tell you what are the roles you need to set it up with. Again, I'm assuming here that you are aware of what an IAM role is. So this is like an intermediate workshop, but always feel free to like ask questions and we can point you to the right solution. Okay, so the next part is the meat of the project. So like I said, this SDK doesn't support labeling jobs. So again, going into it, if you look at the steps, you can see inside SageMaker, it has training step, transform step, tuning step, a whole bunch of things, endpoint steps you can actually deploy using this pipeline, but it has nothing around like a labeling step. And I think it's fine because in the end, it's just a JSON file. So we can take their base class and we can just set all this data ourselves. So I won't go through all of it, but I do want to like point you to something, this funky looking dot, dollar, and double dollar. So this is something called Amazon state language, essentially creating variables inside JSON files. So this double dollar means it's the context object. Essentially, when you run an instance of your workflow, you can get this context object using the dollar. And then after that, you can access all the variables inside. Execution.input is what the input was to a specific run. For example, in this case, if you look at this execution here, and then you can see what was being passed into it. So that's the thing. And we can also point it to like other variables. There's a whole path syntax. I'm not going to go into it, but you can see that whatever is dollar is something that we're going to pass as an input. Okay, so you can go through it. There is more documentation around how do you run this, but essentially we are creating this class that's going to do the labeling job step. Once you define that, you actually want to create a step. So you create an instance, and then I'm adding like a catch, which I showed you here was like, you know, this whole fail safe. So that's where the catch is coming from. Then comes the post-processing Lambda, right? So when you run it, you need to execute the Lambda once your GroundTruth runs. And you already have to deploy the Lambda function here. So keep in mind, using this SDK, it assumes that your Lambda function is already deployed here. I have already deployed these two here. If you want to deploy it yourself, you can go inside the Lambdas, and you have two notebooks that show you how to set up these Lambda functions. And we will go into the code in a little bit. But for now, this is a Lambda function, again, adding some catch. And it also has a retry. So if it fails, you can like retry it. So you can, all of it can be configured here. The second Okay, the Lambda function, this is for notification. So this is essentially going to send you a Slack error, and it's going to go into a failed state. Lastly, just putting it all together into a flow, and a quick peek. It's essentially just a JSON here, and you can see all the different steps are out here, and they kind of connect to each other. The next is saying like, oh, after this, I'm gonna go and run this. Once this is done, I'm gonna run something else. So there is like a retry and catch and blah, blah, blah. So this is the flow. And then we get into like the actual inputs. Like I said, we want to parameterize the workflow so that we can choose which labeling job we are running. In this case, we want to parameterize with the data set name, the field name, which is like what is the field that we're going to label, and the name of the job. So all of that is passed out here. And you can see these names, they are being referred out here as execution.input. So that's how this whole thing works. So that is the input. And I have already created this workflow out here. So what I'm gonna do is I'm just gonna update the workflow here so that we have an instance. Oh, actually it's not found.
May I have your attention, please? May I have your attention? I will be bringing the fire alarm only on the 18th floor. Please disregard unless otherwise instructed. Please.
So as you guys can tell, yes, Kollol is doing a fire drill training.
Yeah, I am. It's not going to happen. When it happens, I will like mute myself. And like I said, oops.
Okay, so as the next steps, we are building the bounding box and creating the workflow. I feel that you need to, like, there's a line below 41, right?
Yeah, so what I'm going to do is, just to show you again, I am going to, hang on, box labeling. I will try and delete this. Actually, I don't want to delete it. You know why? Because this takes a long time to execute. But I will come back to it. So if you execute it, it's going to create a new one. And then we can create this actual workflow. So I have already created MLOps 1 here. Oh, damn. Hang on. We need to create one out here. If I can do this. Anyways, I don't want to delete it because it takes time to create it. But assuming that I've already run this, you are going to get this execution here. And out here, what has happened is it has triggered the labeling job. And you can see the tasks out here that the labeling job has started. And here we have the labeling job. So you can see if you go inside GroundTruth, labeling jobs, this is where we are. And this is in progress, and you can see it's running out here. And the other part is the workforce. So like I said, I had previously set up a workforce with myself out here. And then what you get is a console like this, and you'll get all your tasks in here, right? So this task has come here, which I've executed. And then you basically click on start working. And then the UI that I showed you earlier, that's going to show up here. So this is the tool, a bunch of labels. So let's say we want to mark the merchant name here. So click on the merchant name, and this is Tim Hortons. So we just select it here. And this is one task. You can do things like decline task and stop and resume later. And you can see I've got 16 minutes to execute one single task. So I hit submit. And then there's the next one. This is the merchant name over here. And done. So just two things in there. So it's done right now. And if you go into the labeling jobs, let's just filter it out. You can see I've tried out other things that didn't work. And you can see it's still going through. It takes time to update. And then when it completes, you will see that this would have gone green and then you would have gone to the next stage here. So while that happens, let me just show you the Lambda functions that we have kind of created. So let's look at the first Lambda function, which is set up the labeling, which is this one. And I have a function called post label. And what it is doing basically is just reading the output and it's trying to like parse out whatever is the structure. And you can see there's like a sample here. This is from a single annotation. This is how it will look like. So you can see that you have the image information here and you have the annotations here. And you can see like what was the bounding box and what was the class ID. And then you have another object called class map that says, oh, one maps to merchant name. So that's how this looks like. And this function is essentially just parsing that out. And then you can see that it's saving it into S3. So let's go back and see if it is completed by now. Okay, it is done too, but it's still in progress. Going back. The other Lambda function is the notification function, which is very straightforward. It doesn't do much. And you can see here is we get some event data. I'm just capturing it. And if you work with Slack bots, there's a certain format that you can set it up with. And then if the URL is set, it's just gonna post it and you will get a Slack message that, oh, something is wrong with your workflow. So that's something important when you're working in production pipelines. Okay, so that is the second Lambda function. And this is still in progress. So what we are going to do here till then is we are going to look at the output bucket. So this is the S3 bucket that we created. And you can see the stuff that we copied over is in config data manifest. And the tool is going to actually copy everything into the outputs folder. So you can see this is a job name. And it has this whole bunch of intermediate data out here, like annotations, manifest. What we care about is the manifest folder. So this has the final output. Oh, you can see it has finally generated it. And again, going back, if you look at our post label Lambda function, you can see that I'm trying to read the output out here. And this is where the actual file is. And that file is essentially just a JSON lines file. Let me see if I can pull it for you. That. See if I can pull it here. Oops. This data. This is what we want. Output manifest. And you can see there's a whole lot of things here. Yeah, it's super mangled, but you can see that whatever I did was all this width and all this stuff is actually out here. So this is the file that the Lambda function is going to read, and it's going to parse that out. And hopefully we are done by now. Yep, it's done. So, okay, this should also move soon. Yeah, one of the things is like it's not like super real time. So it takes time till the Lambda function is actually over and it starts executing the next steps. But the Lambda job itself, sorry, the labeling job itself is over. So while that completes, yep, so that's pretty much it for there. I'll go back once that completes, but do we have any questions on the labeling jobs?
I do have a question about how much are things actually out of the box and how much we had to create from scratch. So when you were showing configurations on the screen and that those objects that were helpers, there were some complex configurations. Like how much of that is provided by AWS as templates? So when you were, when you have.
Yeah, so this is, so basically we have to set up the whole, like, the flow ourselves. SageMaker is going to take over. Oh yeah, this ran just now, right? So this completed, and it's done. And then if you go back into I'll answer Daniel in a moment. I just want to wrap it up. So if you go into S3 out here, so go back into labeling, and you can look at data, and you can see that we have generated this JSON file. And again, copy this and just run it here. And you can see that it has done all the conversion. And this is a format that our system is more like compatible with. You can change your post Lambda function to whichever format it works. So yeah, so to answer Daniel's question, we have to put in a lot of the glue together. And then again, AWS itself, the documentation isn't great on how to use a SageMaker labeling job within a step function. It's very difficult. So I had to do a lot of trial and error to figure out, especially how do you pass these inputs. But if you get everything right, it works mostly. So we have been using the system for almost more than half a year, and it seems to be working pretty well. So yeah, hope that answers your questions.
Thank you.
Okay, cool. All right. So with that, that is the section on labeling jobs. Yeah, I don't think we have any questions, so I'm going to be moving on to the next part. So Yeah, before we go on to multi-model endpoints, I wanted to do a quick detour on training jobs. So I think Fred already covered it, like how we train it using their Python SDK. It's not the best. We should use Bodo 3. But then, if you use something like Hugging Face, it's nowadays pretty easy to actually go there and then click a button that will tell you how to deploy it into SageMaker. So it usually works. And we didn't really use that approach. So we use Bodo 3. And a couple of learnings that we have is we found it easier to just put everything into an S3 bucket, put all the code into that instead of like trying to use any sort of like Git helpers that the SDK gives. When we run the training job, we found it easier to pull all the data by passing like a file that had all the IDs. And lastly, when we found that the metrics aren't the best with training jobs, they're very coarse. You get one data point every minute. So if you're looking at loss and things like that, it may not work out very well. And the way you kind of do that is to like put regular expressions. And it is essentially what it does. It just goes and grabs that off the standard out. So that's how it works. It's very like basic. So it can't do much. So what we ended up doing instead is we stored all our metrics in a file within that output. So that Fred was talking about, that spatial directory. So we would copy all the metrics there. SageMaker automatically moves that into an S3 bucket. And we pull all of that, and we have another UI that we built, just like the labeling jobs, where we can see the final metrics in detail. And then we can retrain, and the data team can just, click and train something. So it's not very technical. So that was training jobs. The last topic we'll be covering is multi-model endpoints. So Fred already covered a bit about how endpoints work, but I'll revisit them in the context of multi-model endpoints. But again, to formulate the problem that we had. So we do have a lot of legacy pipelines that run on. We have like a TensorFlow cluster that runs all our models. And we wanted to try out SageMaker because precisely it manages everything for us, right? So we wanted to do that, but we have our own unique problem, is that the kind of documents that we deal with are like quite varied. So we can get invoices, receipts, other purchase documents. They can come from different regions. They might be in a different language. So we need to have different models that deal with all of these different data types. And what we want is that we can run those models independently, but not at the, but it should still be cost effective. We don't want one endpoint for every single model. That's going to be very cost prohibitive, right? Because those instances cost. And then we wanted these other things that I've written here. It's like, it should be easily deployable and reliable, shouldn't be high on maintenance, and it should serve PyTorch. So as you know, TensorFlow serving is fairly mature. For PyTorch, we found that the infrastructure that SageMaker has is pretty scalable. We've actually done a lot of load tests, and we found that it scales quite well. So we're pretty gung-ho on that. A little bit of the diagram out here, you can see that this is our system that we call Hydra. It's an internal name. And it has a model server where we have all our models. And then we have a client that can call into any of them. And we want to make sure that they can run independently, but at the same time, they can scale out. And this is all connected to the rest of our pipeline. So the solution here, actually, let me go full screen. So the solution is, of course, we use multi-model endpoints. And some of the features that each model can get its own worker, it runs in its own process. SageMaker deals with like downloading the model, bootstrapping it up. It takes care of even load balancing and scaling. So if those of you have worked with IAC, you know there's a lot of complexity involved in setting up load balancers and clusters. So all of this is handled by SageMaker. So that's cool. And also it's supported by CDK, which is this IAC that is pretty popular, and we also use it. So that's the solution. So before we go into challenges, let's talk a bit about like how, do you use a multi-model endpoint, right? So it's very clear, multi-model endpoint means you have more than one model in an endpoint. And it's pretty straightforward. You deploy the endpoint in SageMaker, and then you copy your model into an S3 bucket, and you simply invoke the endpoint with the model. It sounds very simple, but of course it isn't that. That's the whole theme of this workshop. So, of course, buggy code, right? So, as of now, the latest version, so they have different framework versions. They have 1.5, 1.6, 1.7, 1.8. 1.8, I still couldn't make it run. TorchServe, which is their new serving infrastructure, didn't work till last April. There is actually a GitHub issue listing. You can see that it got fixed in 1.7.1. We use something pre-TorchServe because TorchServe we feel is still not mature. And we also had to figure out which version to run. Like 1.5 was the one that Amazon tells you to run. Doesn't work. 1.6 doesn't run. There's something called 1.5.1 that we had to use to make it work. So a lot of struggles there. And the documentation doesn't help either. Very little support. So there's lots of challenges there. And of course, it's quite complex. I'll go through the architecture. But we still decided to go for it because the pros kind of overweight like the cons. So we come back into the architecture that Fred referred earlier. So this is how it looks like. But for a multi-model endpoint, you don't actually deploy the model. You only deploy the infrastructure to host the model. So all the hardware, like, all the actual resources like EC2 instances and the Docker container. So all that is deployed initially. And later, you kind of place your code and inference in an S3 bucket. And that S3 like reference is passed earlier when you had deployed the models. You also need to follow a special structure of how you package your model and code. For example, if you have all your model files out here, like, the usual Hugging Face types, you need to create a code directory, and then you need to name your functions specially. So whatever is this name out here that you set, that's kind of the entry point. And when you initially deploy your endpoint, you need to make sure that it is pointing to this file. Inside this file, you have several callbacks. And I'll briefly touch on it now. So model function, this again is called by SageMaker to load your model. So whatever is your model, you should return it. Or you can use it to host some sort of a context sort of a structure. The other important function is predict. So that gets called whenever you're making a call to like invoke the endpoint. And input and output is something to do with the transformation. So we'll look into one of the examples there. Once you have done all of this, you can actually call the endpoint by using this borrow3 function. And you can see you pass the model.tar.gz. That is the one that you packaged here. What this whole endpoint or SageMaker is going to do internally is that it's going to copy over that model. It's going to unzip it. Then it's going to invoke this multi-model endpoint. So a lot of moving parts. So what does it look like, right? So what is really happening under there? So this I grabbed from the TorchServe repository, so GitHub. PyTorch serve, I think it's called. And I've put my annotations in red. And I've put that because Torch serve is something that got forked from another project called multi-model server that AWS essentially has it out. And multi-model server is something that we've been using. And they're almost identical. So you have a lot of parts out here. So there is like a front end which runs in Java, and there is a backend that runs in Python, then there is model store, a lot of moving parts. But what we really care about is like these two parts. So when you kind of run your inference, when you invoke the endpoint, it's going to create some threads inside the front end for every model. And it's going to create a bunch of worker processes for that based on how you configure it. So this deployment is what we are going to cover now. And then later on, we look into how actually deploy two models. So going back, you want to deploy it in SageMaker. So we use CDK. Maybe some of you are aware. So what is CDK? It's the cloud development kit provided by AWS. It is pretty good. We use it in production. It's kind of a hybrid. And again, the reason we use CDK or any sort of IAC is to have good control over your infrastructure, right? When you have a live something that is running in production, you can't just use Bodo 3 to update it. You need to make sure that if something fails, it can roll back, or when you change something, it knows how to track. So this is exactly what you'll get from an IAC. And CDK is something like a hybrid, and it's something interesting because what it does is it takes normal like high-level languages like TypeScript or Python, and then it's going to compile that into what you call as a CloudFormation template, which is a declarative template, and that gets executed by AWS CloudFormation. So we definitely use CDK, and we really like that. So this is the next part. So we are going to go into deploying the system using an endpoint using CDK. And then we're going to look into the other parts. So I'm going to switch over now into another screen. So a moment. Okay, I hope you can see my screen. So
yep, it works.
Great. So this is running VS Code, and if you clone a repository, you'll find the CDK inside multi-model endpoints /CDK/endpoint. So this is all written in TypeScript, and you don't really have to use TypeScript. You can use Python. It supports multiple languages. We just use TypeScript because it's easy for us. So feel free to go through the README. It tells you a lot about like how do you set it up. There's some prerequisites, but for this workshop, I want to walk you through like just the main parts. I mean, CDK itself is a huge topic, so I won't be covering too much of it, but I can tell you some of the main parts. So to kind of look at the entry point, we have a bin file. So this is the top level entry point, and you can see it creates what is called as a stack. So stack is essentially collection of resources, and inside the service stack, we have a whole bunch of things, but the main thing is happening here. So we create our model server. That is essentially the endpoint. That's what we do here, but we also do things like set up a bucket that will hold our models. We create some roles, and we also have other things like endpoint monitor. So this is not your drift monitor, but this is like, okay, you got a error on your endpoint. We need to know what is happening, right? So it will send you in Slack alert if something is wrong, or like look at the logs, point you to the logs. So all of that is done here. So we use something very similar to this in production, and it's fairly stable. So let's go a bit deeper, and I will jump into the model server directly here. Like Fred was saying earlier, so there are three things that are part of the SageMaker endpoint. So one is the model, and then the config, and then the endpoint. I mean, to be honest, I don't really know why it's called a model, because there is no really a model when you use a multi-model endpoint. This is more like a container definition. And you can see things like, oh, this is where we are defining some of these special environment variables. For example, SageMaker program is the entry point. So it's very important you specify the same file name that you actually define your inference code here. And another important thing is this variable. So you'll find issues that people have logged in GitHub saying that, hey, you know what? I have an instance that has 8 cores, and when I run a multi-model endpoint, it's just spawning 2 processes. Like, why is that happening? So that's because when you run it as a container, somehow the container CPU is showing as 1. So I don't know the details of it, but what we found is if you set this variable to the number of workers you want per model, then it's going to spawn them correctly. So this is one gotcha out here. Other than that, we have the endpoint. So you can see all the hardware resources are specified here. Things like instance type, instance count, all that is out here. And finally, the endpoint that takes the endpoint config and the endpoint name. So all these are like classes that CDK provides, and they get translated into this giant JSON. So this class itself doesn't really deploy anything. This is just declaration. Another cool thing that we've also added is auto scaling. So if you use the Python SDK or even the Bodo SDK, I'm not sure you'll get auto scaling out of the box. So what you want to do is when you get more requests, you want to make sure that it scales up automatically. And this was a lot of like hit and miss. There is no clear documentation, but basically you're looking at the number of invocations. That's how it scales. So based on what is the number of invocations you're getting, you can scale this up. We have a top level configuration file that you can like define it here is, you know, at 25%, I believe. Sorry, this is 25. I forget what this exact number means, but this will cause it to scale up once it hits that threshold. So all of that put together here, and I'll show you a quick demo of the system that's working. So what I'll show here, one cool thing is that we can do a diff to see something has changed. So I've already deployed one endpoint, and let's just change this to vector 5. And I need to first compile it. So yeah, I'm build. I'm going to compile the code. And it's slow because Zoom is running and taking a lot of CPU. Wow, that's really slow. Okay, done. So the next thing is we use this script that I've set up, and you can look up the README how to run it. But basically, you do something like cdk me.sh. You can do something like sync that is going to generate the actual output from the, what do you say, the code that we've written here. So it'll translate and compile that into a JSON file. And you can look into that here. For example, this is the one. And you can see it's a giant configuration file. And this is what CloudFormation is going to use to actually deploy the endpoint. And the other thing I wanted to tell you was we can do a diff. And it's going to look at something that's already deployed. And it's going to come and tell us like what changed in the configuration. So this is something that you won't get with Boto 3 or anything. So you can see that it changed from 4 to 5. So it knows exactly what changed. At the same time, you'll see some other weird things happening. We didn't change any of this, right? So why are you getting a new config? Or why are you getting a new model name? So this is another issue with like working with Amazon. Certain things are not what they seem. It turns out that the config and the model, these are immutable. So you can't simply change a property on these things. You have to replace the whole thing. And the only way you can make CDK understand that something has changed is to change its name. So that's what I did. I'm changing the model name. So every time you deploy something, unfortunately, you have to change these things. If someone finds a better solution, like I'll be really down for it, but this is what we got so far. But yeah, so this is how you kind of change this. And now I will just switch over to show you my deployment. So quick change. Okay, I hope you can see the screen. And
Yep.
here, thanks. So here in inference, you can see that we have deployed a multi-model endpoint. And you won't really know it's a multi-model endpoint, so you have to go into the model actually. So it's kind of confusing, like why would you want to have that in the model? You can see this is multiple models, right? So if you come back here and if you look at the, let's go back to the slide. So we talked about like, copying all the code out here, right? So what is really happening, right? So we deployed it and now we want to actually invoke it. And then on the documentation, you will see something like, oh, you call invoke endpoint, pass the model name, and then magically it's gonna call the predict function on this side. It's like, what is really happening, right? Is that some sort of a black hole that AWS has built? That's like the kind of feeling I got initially, like very difficult to figure out. So, and given that things weren't working, it was very important for us to like really understand what's under the hood. So obviously as an engineer, that's what I did next, go under. So this is what I want to walk you guys through, and hopefully it'll be useful. So let's step back. So when we deployed the model using CDK, it had a lot of parameters. And once you deploy the actual Docker container, it boots up this multi-model server, or Torch, which is the newer version. So let's go into what is happening. So we first, I'm just showing the Boto SDK, but might as well have been like our CDK deploy. So next thing is it calls the platform that sets up the infrastructure, calls the Python, the PyTorch container. So we are very specific to PyTorch. If you use TensorFlow or MXNet, it has a very similar flow. So next, it calls, we go inside the container. So I'm going to show you the URLs, and I'm also going to like highlight that how complex it is because there's so many different moving parts. So first, if you go inside this repository, you'll find a file that has this entry point. That's the starting point. Then we go into another project, which is called SageMaker PyTorch Inference Toolkit. And then inside that, there is a file called serving.py. And if you look into that, it's going to call start model server, or in the newer versions, it's going to call torchserve. So like I told you, torchserve is just a fork of the multi-model server, but it's apparently more flexible. So next, based on what you're using, if you are in torchserve, it's going to finally call the torchserve py function. This internally creates things like the configuration file, and it actually runs the torchserve command. For the multi-model server, you can see there's yet another repository that hosts this code. It's called the model server. And then here it has almost identical code, just the names are different. And here also it starts this model server. And then if you go dig deeper, you'll find there are two different projects. One is PyTorch Serve, another is the multi-model server. And if you go inside, finally, there is a model server.py, which starts a Java front end, which is called this. And internally, it might spawn PyTorch like workers. Similar thing for multi-model server. So both of them, they have a Java front end. So this is the bootstrap case. And then finally, when you actually invoke your endpoint, so that we do use Bodo. Actually, one of them is Bodo. And you pass the endpoint name, you pass the body and the target model. What happens next is, again, goes into the platform. It's opaque. We don't really know what is happening here. Like we don't really have access to the code, but we do know something like this happens. So it copies the model from S3. It's super fast, uncompresses it, then it might be doing some sort of a register. So if you look at the documentation for torchserve or other things, there's something called model registration. So I am guessing it does something like that. And finally, it invokes the model. So when it does that, it again comes back to this SageMaker PyTorch Inference Toolkit. And there's something called a handler service. So that's what gets called. And that again inherits from default handler service. And it has a function called handler. So this is like the entry point. And then this is inside that. So it's like called something called transform. And I'm just showing all the code here. So there's transformer.py that calls all this function and finally comes to model function. That is your code that you implemented. And then when you, so for the first time, it's going to call model function. When you first invoke a model, it loads everything. And thereafter, it doesn't really load the model. It calls input, predict, and output function. So this is this giant flow. And knowing this really made it much clearer. So if something was wrong, you know that, this is where the issues are. And that's how we were able to find that some of these versions like 1.5.0 or 1.6.0, they just didn't work. Okay, so let's hop into the Jupyter part of it, the part that actually deploys the models. So we are going to deploy two models. You can go into the multi-model endpoints part. So the container is already, the endpoint is already deployed, but we are going to do the process of packaging the model and then executing it. So let's look into the first one. So set up model one. And I'm just going to make it easy by using a Hugging Face model. So again, if you look at the SageMaker documentation, it's not very clear on how you use Hugging Face models with multi-model endpoints. So hopefully this will give you some guide to like how you can use it. So let's download the model and let's copy it locally. So I think I already ran this before because this takes some time. Okay, so it's gonna copy everything here. Right, model takes some time, but you can see, right? This is the basic Hugging Face model weights and other artifacts. Now comes the code part, right? So like I told you, you have all these files and then you have the inference.py, right? So while it's running, I'll explain what is inside inference.py. So create a code folder and copy the inference. So you can see, just copy this. Another important part is installing the dependencies. So unlike a single model endpoint, multi-model endpoints, each model could have different conflicting dependencies, right? So one option is you could install all of that into your own custom container. But what we found that packaging all the dependencies into the code made it more reliable. So in case if you changed a new model, it really didn't affect others. So this was an important principle that we followed. So once you've installed all the dependencies, you basically just compress it and copy it into S3. So while it's compressing, I'll quickly show you what the code looks like. First, keep in mind the name inference. So this should match what we defined while deploying our endpoint. And you can see it has these different functions: model function, predict function, input function, output function. And what we are doing is this. So SageMaker is going to call your model function and it's going to pass you the model directory. And essentially you will get this directory here, which it has copied over from S3 and then it has unpacked it there. And what we do is we just set up some sort of context. So we create the tokenizer and the model and we just return that. And then whenever you make the call, it will first call input function. It's gonna, and what we do here is essentially load any JSON input into a dictionary. And then SageMaker is just gonna pass that into the predict function. And you can see we're just putting some plumbing code here. I'm pulling out text property and I'm calling predict here. The model is fairly simple. We just, I think this one is for ratings. Each rating is like 1 star, 2 stars, 3 stars, up to 5 stars. So I'm just pulling that out, putting into a JSON object. I'm just returning it. This is just for illustration. If you have a production model, you would be doing way more. You would be doing things like validation. You also want to do things like optimize your models. So this is just for illustration, mind you. So it's tarred. You can see model.tar.gz. And this is the name of the bucket that was created by CDK. You can see that here, right? So it created this. And we are going to now wait. So while that is happening, I'm going to deploy this other endpoint. Okay, so it's copied. And let's look at this bucket. You can see model 1. So this is something I was testing, but this is the model. And now, if you go back into the endpoint calling code, So here, I'm just showing you using Boto3, but we can also use other SDKs. So a little bit of what we have in invoke endpoint. So we basically have the endpoint name. We have the body, which is JSON. And importantly, we have the model name here so that it knows which one to call. Okay. So with that, let's try and call this guy. Fingers crossed. Let's hope it works.
Pray to the demo gods.
So first time what it is doing, it is copying over the S3, the model from S3. It is unpacking it. And then it is calling into like those model functions. Yeah, cool. You can see that it has come back. And now if we like change this, you can see it very fast, right? The first time it takes time to copy over, but second time it's already up there. So what we do in our ISE is when we deploy any new model, we actually warm it up. We send a test request to make sure that the model is up and running so that it doesn't cause any lags. You can also go and look into the logs if you wanted. So for example, let's say this guy here. And I did it. Okay. Yeah. And it has a lot of junk in the logs. The pings get logged every time. People have said that, can we mute them out? But unfortunately, they have not solved this problem yet. So if you look at this, you can see a lot of pings happening. Let's go right to the beginning. Actually, it's too far away. Let's not go to the beginning because I deployed it long back. But essentially, when you run it, you can see that there, MMS worker started. And you can see that the model is loaded. So here, you can call it whatever you want, but internally it has its own like mapping. And then you can see that it has booted our model. And going down. Yeah, I haven't put any logs in there, but you could put logs, but basically you can see what is happening inside your code out here. So this is their first point of debugging if something goes wrong. Okay, so our first model is running. Now to show multi-model, let's try the second model, right? So go into models, set up model 2. Models. Takes a while to download. Okay, so it's saved it here. Again, copy the code, install dependencies. Oh, one important thing you should note here, that I'm using this thing called PyEnv. So it's very important that the version of Python matches what is actually in the container. That is something we can't control. So let's say if you put the wrong version, some of the dependencies may not get installed. For example, we have a library called data classes, which was backported to 3.6. So in the latest versions, you don't really need a data classes package. So if you use, let's say 3.9 here, it will not install data classes. And when you do inference, it'll barf that, hey, I couldn't find data classes. So that's why I use PyEnv. It's kind of versioning. Compress and upload. So quickly showing you what the code up inference code looks like. Everything is identical except that This is slightly different out here. So in our production pipeline, we have multiple models, and we actually use Git to version not just the code, but also the models. So we use specialized configuration files. We could use something like DBC, maybe we'll migrate to that, but we found for our purposes, this was like pretty simple. So that is how our versioning works. So right from training to actually deploying, we can version the model and we can track what we want across different environments. So anyways, let's hope it's packaged, right? It's uploaded. Let's take a quick look at the bucket. Right, model 2 is copied here. And let's see if we can call model 2.
Drum rolls.
And I think we can see the logs here if you want to. Cool, right? So it has come back with a different output. And again, if we change this, second time, it's going to execute very fast. We can look at the logs here. Again, you can see it has started a new model service worker, new model loaded, and it ran everything. So I have not put any logs in here, but this is how we can see internally, like the SageMaker platform is communicating by using all these kind of post requests. So there is no documentation, but you can always like figure out. So if you build your own container, you're supposed to implement these like endpoints that SageMaker is going to call. Like if it is TensorFlow or something, that is how you have to build this. All right, so this too worked. And then we have the torch serve endpoint, right? So I said that torch serve wasn't working. And I wanted to see if, what can we do to make it work? But before that, the torch serve endpoint, again, let me switch my screen, go into, here. Unfortunately, it's still deploying. But if you look at the model server, you can see that it's here. So you can see that we need to pass this thing called an image. And you can go to AWS with the different versions out there. And you can see by default, we use 1.5.1. And I have another command line here, script here, that installs torchserve. And you can see the only thing different is like the framework version, excuse me. And the way Amazon, like SageMaker talks about it is, hey, you have a new version. If you just do the same thing, it should work. But unfortunately, it doesn't. So I was going to show you, but this is taking too long to run. Let's see if we get to that point. Hang on. Okay, so let's just copy it here for the timing. So we're just gonna copy over the model that we built and just copy it over to this other bucket that we have set up. So you can see that. Okay, so we have another bucket that's being set up for the other endpoint. We're just gonna copy it over, and hopefully our endpoint is done. Yep, it's done. Double check. Okay, it still seems to be doing some auto scaling stuff, but I think it's working. So we've copied it over. So now let's just call our new endpoint with this, the same exact same model that we packaged. Right? Didn't work. What happened? The same model that was working for 1.5.1 is suddenly not working. And if you look into the documentation, it doesn't say that you have to do something different. And it gives you this weird error, like invalid model exception. Like, what does it even mean? So we had to like figure out that something was wrong with the input data. And so what we found that there is an additional piece of data that needs to go into a tort serve model. Now, again, I would not recommend doing this. I would say we should wait till they fix tort serve, but just for demonstration, I'm showing this. So we need to use this tool called Torch Model Archiver that is going to add the manifest as well as this handler service. So this is essentially the same thing. I just copied it from their project. And I didn't know any other way than to like copy it over. Maybe in the future they'll fix this bug, but for now it is kind of a bug. So where did I go? Yeah, this one. Right, so we have to call this, and this. Okay, so it copied over, and you can see inside model 1, it has this new MARINF, and has a manifest JSON. So it has some extra information there. So if this manifest JSON is missing, that's when you will get this weird error. Like, that's because it couldn't find the file. So we have to package it, and we need to follow this kind of setup. No archive, there are other options. It just didn't work. So this is how you do it. And start a file. Oh, so package that file. Now this file has an additional folder in it.
And so the only thing missing is the configuration that you put?
Yeah, that and this handler service, because I think what is happening is TorchServe has this new model format called MAR. So it is like a zip file, but has these extra files in it. So it expects this additional information to come in there. I don't really know why they had that choice, but it looks like the new TorchServe package actually requires that format. And hopefully in the future, they'll fix it. So waiting for a bit. Okay, that's done. Let's load model. Done. And now let's hope that this works. So I've switched to model 1B. Cross.
It's already taking a bit longer.
There.
Perfect.
Yeah.
Nice.
So you can see that you won't find any documentation why this was, giving this weird error. And like Fred mentioned earlier, that this is a recurring theme. to do something. It breaks, you have to do something. But in the end, it's a good tool to have. Like for us, it relieved us a lot of workload. So I don't know if all of you are wondering, like, why are you using SageMaker after all this? Like, why not use school ML flow? So I think we actually did a lot of consultation before this. We wanted to know if we should use ML flow, and we found that there is a lot of extra maintenance that required. Maybe over the time we get better at it, but we found that using SageMaker also gives us the advantage of using a certified vendor. A lot of our clients are very, and a lot of your companies, you might have very specific that, part of your, your agreements that you have to use a certified vendor. So for us, we had to use AWS, and it's just easier to kind of build on top of that. So yeah, so that brings us to the end of our workshop. I hope you can use the repository we shared. The CDK part especially is production grade, so you could use that to deploy your endpoints. So yeah, so I don't know if you have any questions, but thanks for listening to us.
I would like to thank you both for the preparation. I know this was no easy feat, and lots of things to prepare. As Kollol mentioned, like in spite of all the issues, yes, AWS SageMaker is still very much worthwhile because we're talking about some development time issues. Once we are actually able to deploy, it scales well, it performs well, and it does reduce a lot of DevOps work from our side, and that is something that it's key for us. Yeah,
that's us.
That's a wrap. So thank you everybody for coming. Thank you, Kollol. Thank you, Fred. And all right, we'll share the materials with everybody. Ciao, everybody. Thank you.